Hello, my name is Zixuan Liu and I'm a PhD student at USC. Today I'm going to share my project Multi-PLD ASL avoids up to 30% CBF underestimation in more than half subjects compared with single-PLD. I have nothing to disclose. As we know, pseudo-continuous ASL is a non-invasive MRI technology. Compared with other technologies, pseudo-continuous ASL is recommended for its higher labeling efficiency, superior SNR, and reliability. It has various applications in brain tumor imaging, stroke imaging, and psychiatric disorder. Pseudo-continuous ASL measurement can be divided into two types, single delay and multiple delay. Both CBF and ATT values can be calculated with multi-delay. On the other hand, single delay is widely used in clinical because it's fast and relatively accurate, but it's under the assumption that ATT is shorter than PLD. However, the heterogeneous distribution of ATT across different brain regions, as well as prolonged ATT due to aging, psychological and physiological changes, can result ATT values exceeding PLD, which leads to the inaccuracy of CBF calculation. Multi-delay ASL can partially solve this issue, but it requires longer scan time. In this study, our goal is to quantitatively compare the accuracy and the reliability of single-delay and multi-delay approaches. In addition, we evaluate the performance of single-delay method when ATT is longer than PLD. To achieve this, we design an MRI experiment using 3T Siemens scanner with 32-channel head coil. The study involved 28 healthy subjects. Resolutions are 2.5 by 2.5 by 3 mm, 40 slices, and a labeling duration of 1.8 seconds. The single PLD was set to 2 seconds, and the 5 PLDs are 0.5, 1, 1.5, 2, and 2.5 seconds. This is a test-retest scan experiment where the single delay uses a single compartment model and the multi-delay uses a model fitting approach for reconstruction. We then calculate the voxel-wise probability of ATT exceeding 2 seconds to determine how many subjects had a prolonged ATT for each voxel. Based on this calculation, we estimate a map of ATT underestimation and subsequently calculate the CBF underestimation for each voxel to evaluate the performance of single delay. This figure displays the average CBF and ATT maps among all 28 subjects. The CBF maps indicate that the 5 delay ASL demonstrate higher CBF values, particularly in the region with prolonged ATT. The ATT map indicates that some regions have ATT values longer than 2 seconds. This figure presents a scatter plot comparing test-retest measurement of green matter and white matter, presented by blue and red dots. This result indicates that ICC for green matter is slightly higher than white matter across both measurements. Furthermore, there is no significant difference in ICC between single and multi-delay for CBF, suggesting that reliability of both measurements is comparable when calculating values across large brain regions. This figure displays a voxel-wise ICC map from all subjects. The map indicates that 5PLD has a slightly lower ICC in some areas. However, both ICC map of CBF from single and multi-delay have high reliability in voxel level. Additionally, the ICC map for ATT displays noticeable heterogeneity. We also calculate the CBF and ATT values as well as their ICCs for smaller regions including frontal and temporal lobes. We will present the data for temporal lobes as an example. From the table, the 5PLD displays comparable ICCs across most regions, which align with the conclusion drawn from the voxel-wise ICC map. Additionally, the 5-PLD shows higher CBF values in most regions. So what happens when ATT is longer than PLD in single delay? We calculated a voxel-wise possibility map, for instance, when ATT is longer than 2 seconds. The result shows that 31% of the voxel and 56% of the subjects exhibit the prolonged ATT. The distribution of the prolonged ATT primarily ranged from 2 seconds to 2.5 seconds. Additionally, the maximum underestimation of CBF values is approximately 30%. In conclusion, our finding confirmed that ATT longer than PLD in some regions. Multi-PLD demonstrates similarly reliability to single-PLD but yields higher CBF values. The fact that ATT exceeding PLD is observed even in healthy subjects, with the maximum CBF bias potentially reaching to 30% due to the inaccurate assumption. Given these findings, we recommend using multiple PLD measurement, particularly for the elderly individuals or in brain regions where ATT is substantially longer. Here is the acknowledgement. Thank you so much for listening. I also share my contact information. Please feel free to reach out if you have any questions.